Creating a rich and user-friendly experience with a GUI takes more than just labels and text boxes. Swing, like other GUI frameworks, provides a wide variety of widgets for making an effective user interface. In fact, there are far more widgets than we have time to cover, but I do want to show you a few of the more common widgets so you can use them in your own programs. Checkboxes, radio buttons, and combo boxes. Each of these widgets has a different role within a GUI, so we'll look at them one at a time. A checkbox is a widget that allows you to make a binary selection, true, false, yes, no, on, off, and so on. You can use a single checkbox, like you often see when you have to agree to terms and conditions, or you can use multiple checkboxes. You might use this to give the user options, allowing them to select as many as they'd like. On a quiz, this would be a multiple answer style question. Select all of the correct answers. In Swing, checkboxes are implemented using the JCheckBox class. The JCheckBox widget includes both the checkbox graphic and the text that goes next to it. Here's how to use it. We'll just declare our JCheckBox objects as fields along with all our other widgets. I'm using CHK as a prefix and then the last name of the individual the user can select. As always, the most important thing about your names is being clear and descriptive. Don't forget that you have to add your JCheckBox instance to the GUI just like any other widget. To see if the user has toggled on a JCheckBox, we can use the isSelected method. We do need to check every JCheckBox to make sure that we cover all of the options, and notice that we're not using any else or else if statements. That's because each checkbox is independent of the others, so we have to check them all. Obviously, you'll end up putting whatever code you need inside each of these if blocks. They're just empty here to keep the code clean for the sake of the video. I just said that each JCheckBox is independent of the others, and a user can select as many or as few as they want, right? Well, sometimes we only want the user to pick one selection from all of the choices. That's the purpose of radio buttons. A radio button is actually the exact same thing as a checkbox, but is generally rendered with a circle and a dot rather than a square and a check mark. Other than that, the only difference is that radio buttons are placed in a group, and the user is only allowed to select one choice from the group. If they select another, then the first choice is toggled off. You could put a bunch of check marks in a group and they'd behave the same way. And yes, if you added radio buttons without putting them in a group, they would behave like independent checkboxes and allow multiple selections. But the subtle difference in their appearance lets the user know how they function, so we should use them in the conventional ways. Learning where the name radio buttons comes from might help you remember how they work. When automakers first started putting radios into their cars, they weren't digital. They had dials and you had to turn them in order to tune to a different station. And in order to remember your favorite stations, they had physical buttons that actually moved the dial to a specific spot when pressed. The button stayed down until you pressed another button, and then your previous button popped back up. Radio buttons in a GUI were named after those old school radio buttons. The Swing class for a radio button is, not surprisingly, called JRadioButton. When we implement it, we're also going to use a class called ButtonGroup. It's not visible in the GUI, but it's necessary to make the radio buttons behave like radio buttons and only allow one selection. The JRadioButton objects don't even need to be near each other on the screen for the group to work. But to make your GUI clear to the user, you should keep a group of radio buttons close together. And you can have multiple button groups with JRadioButtons in them, and the user will be able to select one choice from each group. Here's how JRadioButtons work. Declaring and instantiating our JRadioButton objects will be exactly the same as our JCheckBoxes, which of course is exactly the same as our other widgets. I use the prefix RDB for my radio buttons instead of CHK like for checkboxes. And you also see that I've declared a button group object with the prefix grp. In order to make the radio buttons behave as radio buttons and only allow one selection, we have to add all of the JRadioButton instances to the button group instance in much the same way we add them to the frame. The only other place we see a difference between JRadioButton and JCheckBox is when we test to see which option was selected. Since only one selection is possible, I like to use if-else-if for the checks. That way, as soon as we find one where isSelected returns true, we can stop looking. That's pretty minor, but it is more efficient if we stop once we have a selection. The last widget we'll look at here is called a combo box because it works like a combination of a drop-down list and a text box. It allows the user to choose from a selection of items, much like a radio button, but the user can also begin typing. As the developer, you can decide how the combo box behaves if the user starts to type. A non-editable combo box is probably what you associate with the term drop-down list. The user is only allowed to select from the items on the list, so typing will basically search through the list and make it easier for the user to complete their selection. But you can also make a combo box editable, which means that the list of items is sort of like a bunch of suggestions. The user can pick one of those options, or they can type something that's not on the list. This kind of editable combo box is almost like autocorrect. The user can accept one of the suggestions or just keep typing and put in whatever they want. So that gives us two very different uses for combo boxes. But in either case, a big advantage to a combo box is how little space it takes on the screen. You could give the user a bunch of radio buttons, and that would serve the same purpose as a non-editable dropdown, but you'd be sacrificing a lot of real estate in your window to do it. Sometimes that's worth it, either because you have plenty of space or because it's just really important to make all those choices obvious to the user, like when they're agreeing to those terms and conditions that are so annoying. There is another big advantage to combo boxes that's worth mentioning, even though we'll only touch on it a little bit here. Sometimes the list of choices is pulled from some data source, like a web API or a database. At the time we're writing the code, we might not know what those choices are, or even how many of them there are, so radio buttons wouldn't be practical. It's much easier to just populate the combo box options from that data source when the program runs. To give us all of this functionality, Swing has the JComboBox class. Since combo boxes are all about flexibility, JComboBox has a feature that's probably new to you. It's a generic class. Now, Java generics are a fairly large topic and not really something I'm interested in at the moment, so I'm just going to show you how to use it correctly for now. If you declare a JComboBox in the same way we've been declaring our other widgets, you're going to see a compiler warning. A JComboBox is made up of items, and those items can be lots of different things. I might want a combo box of integers or doubles, for example, so I need to specify that data type. In our case, we're going to use strings. So the syntax for generics in Java is the angle brackets. We put the type name in brackets immediately after JComboBox. And that makes the compiler happy. This doesn't seem like a big deal, so why not just count that as our lesson in generics? Well, for one thing, I can only put a reference type in those angle brackets, not a primitive type like int. As the Beatles themselves once said, you can't do that. You have to use what's called a wrapper class like integer. And that's only the start of the rabbit hole we can end up in. So for now, we're just going to specify our data type in those brackets and set aside generics until another time. Okay, so now we can instantiate our JComboBox and start adding items to it, which works a lot like you'd probably expect. Oops, there's that generic type syntax again. But anyway, we can just add items to the instance with the addItem method. This is a lot like arrays, where you end up having to write a bunch of separate statements to populate all of your data. But there is a shortcut, and it actually uses arrays, in fact. I can pass an array into the constructor call when I instantiate my JComboBox, and the constructor will add all of those elements to the object's item list. Here's an example that uses two different arrays to populate a pair of JComboBox objects. Whether you add the items individually or use an array to populate the JComboBox, you can then add that widget to your frame just like any other widget. Once we've got our JComboBox up and running, we need to be able to see what the user picked. And here's another example of some flexibility offered by JComboBox. We have multiple ways to retrieve the user's selection. Much like an array, the collection of items in the combo box has index numbers, starting at 0. So one way to find out what the user selected is to retrieve that index number. And now I can use that index number in my if statements or however I need to work with that selection. You can also retrieve the item itself using the getSelectedItem method. As part of that JComboBox flexibility, it gets returned as an instance of the object class. Remember that class that every Java class extends from our lesson on inheritance? So to use it as a string, we'll downcast the returned object to a string. And another little peek at that rabbit hole we're trying to avoid. But the syntax is pretty easy. And once I've converted that into a string, I can work with it just like any other string. There are a lot of other widgets available in the Swing framework, but now you know how to use the most common and useful ones for general programs. With these examples, you can probably figure out how to use most of the others. I encourage you to try them out and see how they look.